this setup here. Imagine that we have a vertical turntable. All right, so it's literally the turntable's like this, and this ball is going around like this vertically. Okay, so not looking down on it, we're actually looking like directly in front of us. Okay, and we're shining a light down. A light source is coming down from above, and it's putting it onto a screen. Does that make sense? Pretty easy? Are we okay with that? So that on the screen, we see the shadow of the ball going back and forth, back and forth. Okay? Make sense? Okay, it's going back and forth, back and forth. Now, does that ball exhibit simple harmonic motion?
Yes.
It does, right? Back and forth motion, right? It's oscillating between an amplitude, right? And is in equilibrium position somewhere in here. So it looks like it's a spring, a mass on a spring, right? It shows that same motion. Okay? So what I want to do using that theory, that idea, is I want to figure out how do I find the equation to predict the position of the object, the speed, and the acceleration. Okay? So what we're gonna do here is we're going to rely on a lot of stuff we've already learned. Okay? So it's a nice little review to begin with. So here I've got my object, and I just redrew it and I put it up there, right? Here's my object right here, and I would like to know, right, if this is where the shadow is going to be, this would be a cosine phi, right? Make sense? Right? That'd be a cosine phi, because this is where the position of the ball would be on the screen. Good with that? Okay. So let's start with then x is equal to a cosine of phi, where phi is that angular position. Okay? Now, from uniform circular motion, we know that omega is equal to phi divided by t, right? The angular position divided by the time.
Yep.
Okay? Now, that means then that phi is equal to omega t. Okay? Let's plug that in here. So we get a cosine of omega times t. Now, we also know from circular motion that omega is equal to 2 pi divided by the period, right? 2 pi radians divided by the period to go around that 2 pi radians.
Yeah.
Okay? We could also call it 2 pi times the frequency. Good?
Yeah.
Okay? Now we have it as a function of time. So we get a cosine of 2 pi frequency times the time, which is that equation we learned previously, right, with the pendulum. Same exact equation. Different situation, right? Essentially a mass on a horizontal mass on a spring. It gives you the same exact equation. Right? So that's pretty cool. And again, if you plug in time is 0, time is equal to the period, time is equal to 2 times the period, whatever it may be, that's when you're going to get your a, your negative a, right? Your a all over again. When you've got these things with a cosine of however many radians you have, gives you 1 or negative 1, right? And if you did, what is it pi radians? Or pi over 2 radians, right? Pi over 2 radians, that would give you the cosine of something that would give you 0. That would be at your 0 point, right? Or your equilibrium point. Good? Okay? All right, so this one's pretty straightforward, pretty simple. It took me a long time to figure out or understand how we get this. Right? And this was a really good, this was in your green book. This was a really good way to kind of get there, going from there to show how do you actually get that. In the book, the way we did it before, they just kind of say here's the equation. Well, how do you get the stuff inside the parentheses? Where does that come from? So this does a good job of getting you here. Okay. So what I want to do now is I want to use this information and figure out the velocity, the equation for velocity of this object. Okay? Make sense? All right. So I'm going to slide down a little bit, and I'm going to go with the same situation I already have. Okay? And here is my ball. I'm going to draw it just a little bigger so it's easier to see. There's my speed, right? Tangent to the circle, tangent to the path, that would be my speed. Okay? Now, if I look at it, if I kind of take it over here, this would be my speed. This would be the x component of it. Sorry, did I draw that correctly? I did, yeah. That would be the x component of the speed, right? Just sliding it over, breaking it up into components. Now, I don't care about the y component, because if I'm just looking at the shadow, I don't know if the object's going up or down, right? If I'm just looking at the shadow, all I see is the x, right? So I'm only looking at the x component of this now. Okay? So if I look at that, what I see is that v sub x is equal to negative v sine of phi. Okay? And that has to do with the angle stuff up here. So this is phi. So this is phi.
Gotcha.
Okay? So that's why we do the sine of it to get this. Okay? Good? We're okay? Okay. But I don't want that. I want to know it as a function of time. I want to know it so that I just have to plug in the time, and I'll be able to find out how fast is it going at that moment. Okay? So what I can do is I know that v is going to be equal to 2 pi r, which is your circumference, divided by the period to go around. Right? The time to go around once. So if I plop that in, all right, or I can change it up a little bit, and I can call it 2 pi f, right? And r is the amplitude, right? R is a. So 2 pi over t is really 2 pi f, correct? And then r, our radius, is actually our amplitude, right? Our a over here. So that's where I get that, okay? So that just gives me then v as a function of time is going to be equal to negative a times, where am I? I want to write it a little nicer for you. 2 pi f a, and then sine of 2 pi f t. Because that's phi, right? We found out phi up above is equal to this 2 pi f times t, right? So that's why I just threw that in. So I've got that here. Okay? Are we okay with how I got there? We're good with that? Okay? All right. So next is the acceleration. Okay? So I'm going to take my circle again, and I'm going to look at it in terms of the acceleration. So when I look at it in terms of my acceleration, right, and this is A, this object is feeling a centripetal acceleration this way, right? Correct? It's feeling a centripetal acceleration back towards the center. Okay? And we know that the acceleration is going to be equal to v squared over r. Okay? And from up top here, we know that v is equal to 2 pi f a. Right? Okay with that? So that's going to be 2 pi f a squared divided by a, because r is the radius. In this case, we call it a, right? The amplitude, the maximum amount. So that gives us then the acceleration is equal to 2 pi f squared times a.
So is your radius always equal to your amplitude?
Yeah, because that's going to be the maximum amount.
Okay, so
Right.
radius and amplitude are like synonymous in this situation?
Yeah, because if you look over here, right, that's a good question. When you're right here, right, it's a cosine of whatever this angle is, it ends up giving you 0, right? But when it's over here, this is the maximum radius, it's the farthest out. That's going to be your full A, right, 1 right there. Okay? Make sense? Okay? So what this ends up being, right, this is your maximum acceleration that you can have. Just like this piece right here is the maximum speed you can have. Because that's when this thing is equal to 1, right? When this section right here is equal to 1, that's your maximum speed. Are we good? Okay. So what I want to do is I need to throw that into, get the full thing now, right? That's only the maximum acceleration. That's not the acceleration at any point. Okay? So to do that, again, I know that that is a sub c, but that's the x component of it that we want, right? Because the y's don't matter for us, because they don't show up on the screen. We only see the x component of everything that happens, okay? So in that case, that's a sub x is equal to negative a cosine of phi. Right, again, it's negative because here's your phi right there, right? And that's your adjacent side. So that's where we get the cosine from, okay? We call it negative because it's going in the negative x direction. Okay? So we know a is equal to negative 2 pi f squared a. And we know that cosine, and we remember that phi is 2 pi f times a. I'm sorry, t. What am I throwing that in there for? T. Okay? So just to separate a little bit, that's equal to negative 2 pi f squared a cosine of 2 pi f t. Okay? And that's that. Make sense?
So that's
Yep.
acceleration at any point?
This is the acceleration of that object at any point. Go ahead.
So is that the same as the velocity except with 2 pi f squared?
And it changes from sine to cosine.